Hey, what's going on, everybody? Welcome back to Civil Engineering Academy. My name's Cody. Let's go ahead and get started. So today we have a hydraulics hydrology problem, and in particular this is going to be an open channel flow problem, and we're going to be solving for the hydraulic radius. So here's what the question says: determine the hydraulic radius of the figure below. And we see our four options there in feet, and then we see our diagram here, or our figure, that we're going to be using to solve for this problem. So it tells you exactly what we need in the problem, the hydraulic radius. And so if you search in your formulas for those, you're going to be finding it in the PE on page 345. Okay. And then in the FE, you're going to be in 296. And so whenever you look on those, you should end up with a formula that looks a little bit like this. The hydraulic radius is equal to your area over your wetted perimeter, and sometimes I'll throw in this W right before the P. Don't be alarmed either way, it just means wetted perimeter. So we see everything that we need to solve for. We just need the area and the wetted perimeter. So to solve for the area first, we need to keep in mind the only thing that we're worried about right now is really the water aspect of this. The problem says that there's 1 foot of freeboard. So that means that it's just open air, there's no water. So we're just going to exclude that from our calculations. And so we're going to use this depth here of 4 feet for our calculations. So for this area, the trick to this guy is really just split it up into sections. And so we can have a rectangle here, triangle, and triangle. And so that's what we're going to do. So zooming in real quick to these triangles, you can really mess this up in multiple ways. We see that our water level is 1 foot below, like I said earlier. And so the depth, or the dimension here, is actually including that airspace. And so we don't want to do that, right? We don't want to include that. This guy's 4 feet. And so the way that we get by with this is we create similar triangles. We understand this is 1 foot up here. So doing that, we know that 2 is associated with 5, and that's going to be equal to something associated with 4. And so what we're solving for is this dimension right there. That's literally what we're solving for, is the length along that side. So whenever you do that, you end up with 1.6 feet as that dimension, and so we're going to use that in our area calculations. So moving on here, we're going to include that first triangle, base times height divided by 2. So our base is 1.6 feet, our height is 4 feet, and then we're going to divide that by 2. And so we're going to add our next section now. This next section is going to be this rectangle that we created, this 5 by 5 rectangle. And so I just kind of hinted towards it. The area is 5 feet times 5 feet. And then we're going to add the next rectangle. Let's just work from left to right here. The next rectangle is 4 feet by 5 feet, so 4 feet times 5 feet. And then we have another one of those triangles that is 1.6 feet. Got ahead of myself. 1.6 feet times 4 feet, and then we divide by 2. So whenever you add all those guys up, your area should end up being 51.4. So 51.4, and that is square feet. Okay, so we've solved for half the equation now. Now we need to solve for the wetted perimeter. And so to do that, we are concerned with every piece of material that is touching that water in our open channel. And so that is just this part. That's all it is. So doing that, our P is equal to, well, we need to solve for this side. We need to solve for what this hypotenuse is. And so a squared plus b squared equals c squared. You end up with the square root of 18.56. And so this is using that 1.6 feet. So 1.6 squared, I'll go ahead and do it, plus your 4 squared equals your c squared, and so that's where that square root came from. And then we're going to add our next side, which is 5 feet. Okay, and then we're going to add the bottom of our channel, which is 5 feet, other side of our channel, which is 5 feet. and then we add that square root again, so 18.56, boom. And so your perimeter should end up being, let's see, 23.62 feet. So now let me scroll down just a little bit. And so doing that, our hydraulic radius is going to be that 51.4 feet squared over our 23.62 feet. And so this guy ends up being 2.18 feet. And so something that you'll notice is if you use that 5 feet as your total height with your triangles, you'll end up with 2.72. So you'll notice that is an incorrect answer. That's B. And then if you use the total 2 as your triangle instead of that 1.6, you'll end up with 2.21, which is also incorrect. They kind of show it in A. And so yeah, so you could have gotten this guy wrong multiple ways. And so the answer in this one is going to be C. So I hope this video helps, and we'll catch you next time.